Hello, AP Stats. This is Mr. Kim once again, and this is for the Chapter 2 FRAPPY. I want to go over this with you guys just very, very briefly because this is probably one of the easiest FRAPPYs that I've ever given out. So for number 5, we have basically the distribution of high school A and high school B with the number of teachers with how many years they have on average, I believe. And so we have 200 teachers in school A, 221 teachers in school B. We want to figure out the median for part A. It says that the median for one of these schools is 6. The median for the other school is 7. So what will be the best way to approximate this is the question. Now, if you take a look at these values here, it's very hard to determine it, but I would guess that that's 46 and like 48-ish or so. And so if we're looking at 200 teachers at high school A, we want to find out the 100th number because that's going to cut this 200 data sets into half. And so even if I were to add these two numbers, you're still short. So your median will most likely fall under here between 7 to 10. Now, if you were to do the same thing with 221 teachers, you're still going to be looking for the 100th number, or the 101st number to be exact. That comes up to be 79, and that comes up to be around, I would say, 34, which already gives you more than 100. So you're pretty much looking at the median to be between 4 and 7. So what does this tell you? The one that has the median of 7, it has to be school A. So the median of 7 has to be school A because the median is between 7 to 10. The 100th number is between 7 to 10. So the only possible scenario where median is 7, it has to be this. Can't have a median of 6 because it's too short. 6 definitely then is school B because the median is between 4 to 7, which means it gives yourself a little bit of room of space in saying that, you know, it can be anywhere between 4 and 7, so it could be less than 7. So that should be answered for part A. An additional 18 teachers were not included in the data set from the 200 teachers. Now, the good news is that they give you that the mean is 8.2. So if the mean was 8.2 for all these 200 teachers, what you can do is this is the total over 200 because it's the addition of everything divided by how many numbers there were. So if you were to figure out what the total is, that would be 8.2 times 200, which using my calculator here, which that would give me 1640 for the total average or total years of the years spent at school for the teaching years by the teachers. Now, for these 18 teachers, the mean is 2.5. So you do the same thing. So total over 18. So the total for these 18 groups of teachers will be 45. Now, with these two, you can add them simply, which gives you a grand total of 1685. And then you will divide that by total number of teachers, which is 218, which will give you the final average to be about 7.73 years, teaching years spent at this particular school. Okay. All right. Now we're looking at part C. The standard deviation is 7.2. If one is selected at random high school B, what is the probability the teaching year for the select teachers will be within one standard deviation of the mean of 8.2, it says. Standard deviation, okay. Is one teacher selected at high school B, what is the probability the teaching year for the selected teacher will be within one standard deviation of the mean of 8.2? Okay, so it seems that we have an 8.2 here as a center, and the standard deviation is 7.2. One standard deviation of the mean of 7.2 would be 1 here, and then 15.4. So we're looking at about this much right there. Within one standard deviation of the mean of 8.2, you can use normal CDF to do this. So if I were to show you the exact steps, I'll just have to type in NJSLA test once again. Ooh, so let's let me just go here, NJSLA practice test, math tests, algebra 2, unit 2. Okay. All right, so if I were to do the normal CDF, so second vars, normal CDF, with a lower of 1 and upper 15.4, 8.2, standard deviation of 7.2, and that would give me about 0.68268. But you know from the empirical rule also that moving one standard deviation will give you about 16% of the data. So when you're justifying your answer, you can say that you use normal CDF, or you can say that you use the empirical rule to figure this question out. I don't think there's going to be too much problem if you said either way. The second question is even easier. We want to mark and label the box plot for the median and the interquartile range. I would say the median is somewhere, I would say about 21-ish or so, median 21. The interquartile range, I would say that's about 18-ish or so, with this being 25. So IQR being about 7, Q3 being 25, and Q1 being about 18 or so. What is the approximate value? So I think you could just say that, and I don't think there's going to be any problem. Part B, the federal tax imposed 18.4 cents per gallon at the time. So were in effect, the federal gas tax was added to state gasoline tax for each state to create a new distribution of combined gasoline taxes. So what that means is that this is the federal government state law, federal government law for the taxes. Now, the federal tax imposed on gasoline was 18.4 cents per gallon at the time when the state taxes were in effect. So what that means is that this is going to get added on top of all the state gasoline taxes that's already in place, basically. So when these are going to be added, what are approximate values in cents per gallon of the median and the interquartile range of the new distribution of combined gasoline taxes? So the median, how would it change? And IQR, how would it change? Guys, remember, when you're adding or subtracting, the only thing that changes is the center. And for multiplication and division, the center as well as the spread changes, which includes the IQR as well. But we're not talking about multiplying anything or dividing by anything. We're just talking about this, which means the spread stays the same. How do you justify your answer? Well, if you just add 18.4 to both of these state law taxes, Q3 and Q1 that we found out, and you were to still subtract them, you will still get 7. You can verify that mathematically. Now, the next part is finding the median. The median here is 27, but because we added 18.4 on top of that, so you can just add those two up and it will be 45.4. Remember, the center, median, and the mean always gets affected by adding or subtracting the values to the data sets there. Okay, very simple FRAPPY here. I hope that this wasn't too much of a big trouble for you. I hope this helps in understanding the free response questions that you'll be doing tomorrow, and have a wonderful day.